Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating systems. This subject is for the students studying in the 5th semester of their BSc degree program. This paper operating system belongs to paper number 8. In today's lecture, we are going to see few topics from unit 5. In unit 5, there are several topics, out of which we are going to see topics such as I/O system, overview of I/O system, I/O hardware, application I/O interface, kernel I/O subsystem and transforming I/O request to hardware operation. So these are the topics that we are going to see in this lecture. So the contents of the day are I/O hardware, application to I/O interface, kernel I/O subsystem, transforming I/O request to hardware operations. Now, what is an I/O system? I/O system is nothing but an input-output system. What are the input and output devices? You might be knowing several input devices and other output devices. What is an input device? The keyboard is an input device. Mouse is an input device. What are the output devices? The monitor is an output device. The console. What is a console? Console is any output device, you call it as a console. So the monitor is an output device, the printer is an output device, the projector is an output device wherein it gets you can see pictures on the screens. So these are the certain output devices. And as far as input device is concerned, other than keyboard and mouse, even the scanner is an input device wherein you scan the item and it gets stored in the hard disk. So we are going to see this input and output devices, how it interacts with the system. That is our topic for this lecture. What are the input and output devices? How it is going to interact with the computer, with the operating system, and how it is going to, how the operating system is going to map with the I/O devices and how it works. So that is what we are going to see. Now let us see about an hardware, about I/O hardware. What is an input and output hardware? So even for an input device, you require an hardware. Then only the contents, if you are going to give an input, if I am going to press a key in my keyboard, it should be typed on a Word document or on a notepad or on a command box, right? So if it is not going to type, then which means the keyboard is not detecting. So if I want to make the keys whatever, if I want to type something onto the system, consider opening an MS Office, MS Word and typing certain contents in MS Word. So if I want to type something, if I want to enter a name, how are you, that how are you, HOW, it should be printed, it should be typed on the screen, on the Word, MS Word letter. So MS Word page. So in that case, if it is not going to type, which means that the keyboard is not working. So even this keyboard has a hardware, and this keyboard has to interact with the computer, with the operating system in such a way that when a key is being typed in, pressed in, that key has to be entered, that key has to get displayed on the MS Word document. So for that it requires an hardware, that is called IO hardware. In a similar way, if I am going to have a mouse, if I am going to click this mouse, it should click on a proper, that cursor should point to a proper location, and whatever I require, it should click onto it. If it is not clicking, if the cursor is not at all moving, then it means the mouse is not working. So similarly, so any input device or it may be an output device, for a printer to print, it should receive certain command from the computer, from the operating system. One and only if it receives the command, the pages will get printed, or else it will not get printed. So all these things require a hardware device to communicate from the device, either an input device or an output device, to the computer system. So that is what we are going to see now as an IO hardware. So for the IO hardware, we require the incredible variety of IO devices. So we require the storage, transmission and the human interface. Storage in the sense, whenever I am going to type in a key from the keyboard, that has to get stored in the page, and internally it has to get stored in the hard disk, in the secondary device, in the disk, and internally the count value, the size of that page has to get increased. If I am going to press a button called A, key called A, it has to take 1 byte, and that 1 byte has to get incremented in my memory, and if I am going to delete, similarly it has to get decremented from the memory. That is called, so that is where the storage is into effect. And then the next thing is the user interface. See, if I am going to type ABC and if it is going to print as DEF, then it means that it is not properly working. It means that keyboard is not properly working. So human interface is also required and storage is also required. So similarly, the transmission also required. If I am going to type A, B and C, it should type only A, B and C and it should not type otherwise. And the human should check the correctness of the system. Now the other common concepts in IO hardware are signals from IO devices interface with computer. What are the signals? How do we interact with the IO device, input output device? Let us consider this keyboard with the operating system. So we require some wires, or even the keyboard may be connected using wireless through Bluetooth. So even for that we require a port, we require a bus, and we require a controller. So what is a port? Port is connection point for any device. What is a bus? Bus is a group of wires. I suppose when you are using older hard drives, it would have got connected through only through bus, only through an IDE, and nowadays the hard disk get connected through a SATA device, wherein you have only a thin set of wires. In olden days, it is the olden hard disk used to get connected to the motherboard using a bus. Bus is a group of wires that has been transfers the communication from the hard disk to the motherboard or to any other part of the operating system. So bus is a very good example for communicating between the hard disk and the motherboard. Then the third one is said to be the controller. In the controller is said to be a host adapter, the electronics that operate port, bus and device. A controller is something like a plug. If you are going to press the plug and if you are going to switch it on only, the system will be working. So that switches, it controls the entire computer to work, and that acts as a controller, or it is a host adapter. Then the other common concepts are all these controller, port and bus should sometimes it needs to be integrated. So sometimes separate circuit board is required in the case of host adapters. It contains processors, microcode, private memory, bus controller, etc. So these are the different IO hardwares. Now let us see the application to IO interface. What do you mean by application? See, application is what we are going to use. So, what is an interface? Interface is when we have an IO device, a keyboard, we have an operating system. From the IO device, the keyboard, to the operating system which is present in the computer, in the CPU, right? What is the interface? What is the communication channel that is between an input device with the operating system, or what is the communication channel with an output device from the operating system? That is what we are going to see. So, what are the applications? So, IO system calls encapsulate device behaviors in generic classes. Device driver layers hides differences among IO controllers from kernel. Kernel is a nucleus of an operating system. New devices are already implemented protocol, need no extra work. Each OS, each operating system has its own IO subsystem in it. And then the next is devices vary in many dimensions. So, what are the dimensions in which devices vary? First point is it varies based on the block or a character stream. Second is it varies based on the access methodology. The access methodology we have seen much in detail in one of our earlier lectures. We have two different accesses. One is a sequential access, other one is a random access. So, this access methodology varies from system to system, varies from operating system to operating system. In Unix, the access methodology may be different. In Windows, the access methodology may be different. In Solaris, the access methodology may be different. So, these are the it varies according to operating system. The other point over here is it should be synchronous or asynchronous, or it may be both. The IO devices, it should be kept on a shareable means, or it should be dedicated. And the speed of operation even depends upon the system to system. Supposing if you are going to use, if you have bought your computer somewhere in 2005 or in 2006, let us consider. At that time you would have you would have had a processor by name Pentium 3 or the maximum of Pentium 4. So, but nowadays when you are going to buy a new computer, the processor that is required is you will be getting only Core 2 Duo or dual core or quad core or something of the sort, or something like an i3, i5, i7. So, when you could work now, say for example you are working in a quad core machine now, and when you have been asked to work in a Pentium 3 machine, now you could definitely feel the difference in speed of execution. So, the speed of execution also depends on the devices that you use in your system. The next one is about the read only or write only applications of an IO interface. So, these are the various dimensions that are possible in an IO application. Now, let us see how this IO subsystem works. IO may be a system or it is a subsystem. Why do we call it as a subsystem? What is a subsystem? What is the difference between system and subsystem? Subsystem is a part of the main system. See, we have an operating system as a whole. In the operating system, we have an IO system. We have a process. We have a CPU schedulers. So, this IO system is part of the entire operating system, and henceforth it is called as a subsystem. Now, let us have a detailed look of how this IO subsystem is being placed in the kernel, or how it impacts with the kernel, and how the communication transfers from the IO device to the operating system. So, here is a diagrammatic here is a figure which says about the kernel IO structure. We have a kernel and we have a kernel IO subsystem, and let us see this figure now, and we will continue the explanation of this kernel IO subsystem after the break. Welcome back after the break. We were discussing about the I/O subsystem and the applications for an I/O interfacing. Now, before the break, I showed you a figure of a kernel I/O subsystem. Now we will continue with the kernel I/O structure. Here in the kernel, we have the software wherein this is to be the kernel, which is said to be nucleus of the operating system. We have a kernel I/O subsystem and we have SCSI device drivers. SCSI is nothing but small computer system interface. Small computer system interface device driver, and we have one other device driver called as keyboard device driver, mouse device driver, so on, and we have PCI bus device driver. PCI denotes peripheral component interconnect, and we have a floppy device driver, ATAPI device driver. ATAPI denotes at attachment packet interface. So we have these many device drivers that is been kept in the operating system. So this device driver, with the help of this device driver only, we can make our communication to we can communicate from the I/O device to the operating system. So these device drivers are being placed in the kernel of the operating system. Now in this figure, after this device driver, we have a in the hardware part, these are all said to be the software part. These device drivers are said to be the software part, and that is the reason when you had an experience of installing an operating system, then at times your speakers may not work, at times your keyboard may not work properly. So at times there may not be a proper resolution in your computer. So what do? You just like that, you take the motherboard CD and then you plug it on and then you install the motherboard CD drivers. So all those drivers are said to be these drivers: SCSI device driver, keyboard device driver, mouse device driver. So based on your requirement, you will be installing those drivers, and all those drivers happen to be softwares will be placed in this kernel. Now in the hardware part, we have a SCSI device controller, keyboard device controller, mouse device controller, etc., PCI device bus device controller, floppy device controller, and ATAPI device controller. So this communicates from this software. SCSI driver communicates to SCSI device controller, and this device controller in turn communicates to the hardware devices, input output devices. Devices such as SCSI device controller communicates to SCSI hardware, keyboard device controller communicates to keyboard, mouse device controller communicates to mouse, PCI bus device controller communicates to PCI bus, floppy device controller communicates to the floppy disk drives. There is nothing but the removable drives. Nowadays many people are not using floppy drives, instead they use the USB drives, pen drives, and this ATAPI device driver communicates to ATAPI devices. ATAPI devices are certain disk. Disk is nothing but the compact disk. Compact disk is nothing but the CD-ROMs. So CD-ROM, disk, tape drives, so are all these things come under an ATAPI devices. So all these things communicate, and this is an example for an kernel I/O structure. Let us now see how this kernel I/O has been scheduled into. So this kernel I/O is scheduled in many different ways, out of which the first way is it uses a scheduling. So some I/O request orders via per device queue. So at a time when you are going to give an input of, say for example, you want to print a page, and at the same time you want to view a video, you want to view a picture using projector. So you give those requests, and based on the device request, this gets executed. So some OS try fairness in it, and some implement quality of service in it. This is said to be my first kernel I/O subsystem scheduling. Second is buffering. What is buffering? Buffering is storing data in a temporary region. So buffering is useful for faster execution. One and only if it buffers, you get a faster execution. I suppose you would have watched videos through a website called youtube.com. So when you watch a video through youtube.com, Supposing if the internet speed is pretty less, what happens? It will not be buffering. That video will be hanging, and then after few seconds it will again start to playing, and after playing again after few seconds it will get hang, and then it starts playing. So this is what is buffering. If the buffering is proper, it is used for faster access. If the buffering is proper, video will be played properly. So that is one other kernel IO subsystem. And then next kernel IO subsystem is, third one is caching. What is caching? Caching is faster device holding copy of data. What is a cache memory? Cache memory is, it has a small amount of memory, something like a buffer memory. So the entire data is available in a hard disk, in your secondary disk. So if you want to play it, what happens is that if I am going to play from the secondary disk cannot run at the speed of a main memory, at the speed of RAM. So what happens is that I take few items from the secondary disk. If it is of the entire movie video length of, say for example 35 minutes, the first 3 minutes it will be put on the cache memory, because the cache memory has a less storage space. From the cache memory it will go to the main memory and it will execute it. So this is more faster when compared to directly working from the secondary memory. So that is called as a cache memory, and that is a part of kernel IO subsystem. The next one is spooling. What is spooling? Holding the output for a device. So simultaneous peripheral devices online is called as spool. Simultaneous peripheral devices online is spool, and spooling is holding output for a device. If the device can serve only one request at a time, then that is called spooling. So say for example, you are given a print, and as well at the same instance of time you are given a projector request. At the same instance of time you have typed in YouTube and you wanted to watch a video. You would have definitely you would have definitely seen that here there is a possibility, like in your operating system there will be a small hiccup in its execution. You would have seen it, notified it. That is because printer you are given a request, at the same time you are given a request for projector, at the same time you wanted to watch video. So all these operations has to be spooled together, has to be queued together. Spooling is nothing but queuing. So has to be queued together. So based on the priority in it, it gets executed. So that is one of the kernel IO subsystem. The next kernel IO subsystem is device reservation. This device reservation, it provides exclusive access to a device. So the system calls for allocation and deallocation of the devices, and then it watch out for deadlock. So say for example, this is a case wherein you have a computer, you are being connected to a network. What is a network? There are 10 different computers, 10 people are working, you have a common printer. If 3 people, consider 3 people are giving a printer request at the same instance of time. One is a manager, one is you, an employee, just a developer in a software company, one is the peon of that office, and definitely the priority assigned to a manager will be pretty high when compared to you, and definitely the priority assigned to you will be pretty high when compared to the peon who is using the computer. Supposing if he is being allocated a separate computer, consider if he is not using a computer that has been assigned to a different employee. If a computer has been assigned to him, then a peon may be having a lower priority when compared to you, and you may be having a lower priority when compared to the manager, and all 3 are giving the print request. What happens? Fortunately or unfortunately, you are giving the print request at the first, and you are asking to print for 300 pages, and your manager is asking to print only 3 pages, and the peon is asking to print 10 pages. So what happens? Since the priority assigned to the manager is pretty high, the manager's printout will come first, and then yours, and then the peon's. So this is been allocated by the operating system and this kernel IO subsystem is called as, such a type of kernel IO subsystem is called as the device reservation. So this device gets reserved based on the priority assigned to the computer. The administrator has more priority when compared to the normal user, when compared to the guest, when compared to the other users. So he has the full control of the computer, whereas the other users, he may or may not have the full access to the computer. So this is one other kernel IO subsystem. Now let us see how this IO request will get transformed to a hardware operation. That is said to be our next topic, how this IO request gets transformed to the hardware operations. So here let us consider reading a file from disk for a process. Determine device holding file. Translate name to device representation. Physically read data from disk into buffer. Make data available to requesting process. Return the control to process. So this is how we transform the IO request to a hardware device in order to carry out the operations. Now let us see the performance issues in terms of IO subsystem. Again, IO is in order to have performance, this has to communicate properly. One and only this device, that is the keyboard device or any input device, is communicating, the system will be responding. One and only if the printer is communicating, the system will be responding properly. Supposing if the printer cable is not been plugged properly, supposing if there is an issue in plugging the printer cable, or if some rat or someone has because of some reason, if the printer cable is torn, then what happens here is there will not be the sufficient sufficient information will be shared from this computer operating system to the device. So you are, in order to check the performance, the port, the bus or the port or the controller or the adapter, whatever we say, has to be in a proper way so that it enhances the communication between the IO device to the IO system, to the computer operating system. Then only this device, this port, bus and the controller, if it is not proper, if any one of these devices are not proper, then this IO device will not work properly. So let us see the performance involved in this IO subsystem. IO is a major factor in system performances. So the first point is, it demands CPU to execute the device driver and the kernel IO code. What was there in the kernel IO code? In the kernel IO code, all the device drivers were there. So all the softwares that has been installed, I gave you an example with respect to installing an operating system by your own. So in that case, if you are going to install an operating system, at times the speaker may not work properly, at times your resolution in the monitor may not be proper. So what you do is, you just put your CD and then you install the device drivers. So that should be there. The second point over here is the context switches due to interrupts, and the third is data copying, and the fourth is the network traffic, especially it should not be stressful. That is, if you are going to have your printer on a network, it should not be stressful. Now let us summarize whatever we have seen so far in today's lecture. So we have learnt about what IO system is and what is an IO hardware. We have discussed about the applications of IO interfaces. We have seen the kernel IO subsystem and its architecture. We have learnt how to transform IO request to hardware operations. Now let us see the possible questions that could arise from today's lecture. So question number 1, what is an IO system? What is an IO hardware? What is a port? What is a bus? Mention the different kernel IO subsystems. What are the major factors in IO system performance? So, with this, we come to an end of today's lecture. We will be seeing more topics in our forthcoming lectures.